Welcome to this video on Zero Trust Architecture. As a part of CISSP exam outline, you are expected to understand Zero Trust Architecture, trust but verify and shared responsibility as part of the secure design principles. So that's what we will focus on this video. Now, Zero Trust is a little bit different of an approach as opposed to modern day security that we are familiar with. Instead of trusting certain object and resources within the system and subject as well, really nothing is automatically trusted here. So as we are building within the architecture, we want to make sure that trust is continuously evaluated within the information system at all the times. Now, trust but verify is a bit different, where there is that inherent trust, but we verify that we trust you. So if you are actually operating, let's say you are the system administrator down here and you are behind the firewall, which is backend, and you are accessing the storage server, the application server, the infrastructure servers, and you are doing your normal stuff. There is a certain level of trust that you are allowed to be here. No one checking the IP on this workstation and filtering on that IP. No one sending you to the firewall and checking traffic. You certainly can, but for the most part of the system, do not do this. That is a certain level of trust. We trust that you are allowed to get there. We are not filtering. We are not using like a host deny or host allow on a Linux platform or something back here, or host file on Windows. We are just literally allowing anyone to SSH to this box or connect to this box on whatever port are open. Then we are going to verify. Then we are going to authenticate you. That's the trust but verify. You are supposed to be here. We think you are supposed to be here, but we just want to make sure that you are who you say you are. There are also some systems that will actually give you access to stuff while they are doing the authentication and authorization behind the scene. That's also a form of trust but verify. Zero trust minimize all of that, gets rid all of that. There is nothing assumed within zero trust. It will enforce least privilege on a per request basis, and it will minimize that uncertainty because it focuses on real-time authentication and authorization before you get access to the resources. And it also reduces what we call implicit trust zone. And what I just showed you with that trust but verify was an implicit trust zone. You are behind the firewall. Things are safe. Things are great. Things are awesome. They might even serve drinks back there. It's all nice and all back behind the firewall. But in reality, we should not trust that. We want to minimize those uncertainties in subjects and what objects are trying to access. We can't eliminate them, but we can minimize them. And that's the focus on the authentication and the authorization. And then maintaining availability of those assets once they access them. Now, the best guide that I found that explains Zero Trust Architecture is the best NIST Special Publication 800-207. You might want to know that for the exam. This lays out all the different principles of Zero Trust Architecture, starting with all data sources and computing services are considered resources. We treat them as resources. They are not really object anymore. They become resources. All the communication is secured regardless of the network location. So even if you are behind the firewall, we are still encrypting that traffic to prevent it while it is in transit. To individual enterprise resources is granted on per session or per request basis. So now every time you want to go and access the object, you are checking authentication. You are checking your authorization and making sure that you are allowed to access that. Where in Zero Trust, everything is checked and verified in real time. So if I revoke your access, the next time you try to access an object, it's going to check against your authorization and then deny your access to that object. So that's the point behind the number 3 here. Number 4 is the access to resources is determined by dynamic policy and may include other behavior and environmental attributes. Now we will get into behavior analytics and other stuff like that later on this training. But really what we are talking about is you are looking at the state of what the subject is doing. You are looking at the state of the identity, the state of the service they are trying to access, the state of connection, things like that. And the policy is dynamically adopted to the based on the state of the connection and also the behavior attributes that are being exhibited as well. Number 5 is the enterprise monitor and measures the integrity and the security posture of all owned and associated apps. So we are monitoring and we are measuring how accurate all of our authentication and authorization mechanism are in terms of security posture of the designers. Number 6 is all resources, authenticate and authorization are dynamic and strictly enforced before access is allowed, and that goes back to everything's being done in real time. That way if there are changes to the authentication or changes to the authorization, they will be caught on per request basis, and that will prevent a subject from getting unauthorized access to an object or a resources in this case. Number 7 is that enterprise collect as much information as possible about the current state of assets, network infrastructure and communications and use it to improve its security posture. What we are talking about here is really we are looking at system analytics, network analytics, and we are looking at big data kind of stuff, if you will. We are collecting as much data as possible using our security information and event management, using our audit log, using system log, all those different things. We are aggregating these together and we are trying to understand the different behavior patterns that are happening within the system. So these 7 principles, if you will, these are focused more on system side of things. We are there also a piece that focus on the network side of things, and this is where we are talking about private network and public network. Private networks are not considered as an implicit trust zone. A lot of times in a system design, if you understand public and private network are not routed in open network or open internet. Not that they can't be, but they are not. This is your 192.168 space, your 10 dot space, and your 172.16 all the way up to your 172.13 space. Those are your private network space. Those will not be routed by internet service providers. There's this implicit trust that if you are coming from a private IP, it's safe. You are on the inside of the system. You are not coming from the outsider world. In a zero trust network, you do not trust this. Doesn't matter what your IP is, because you cannot do a lot of different things. Network address translation, you can change your IPs, you can spoof IPs. There's a lot of different attacks that can happen, and because we do per request basis and no implicit trust, this will make sure that it doesn't matter where the IP is, regardless of location, you will be authenticated and authorized based on your identity. Then number 2 is device on the network may not be owned or configurable by the enterprise. This one is actually pretty simple when you think about it. We are not going to own every network device or endpoint device that connects to the network, such as bring your own device. When people bring mobile phone or their tablets to work, or they are plugging their laptops in, or you have a contractor or visitor coming in, or maintenance personnel coming in to help, this may not belonging to the enterprise. They may belong to another company or another individual. So we want to treat them as untrusted and make them authenticated and be authorized to get access to the resources. No resources on the network is inherently trusted. Again, that comes back to the zero trust mentality. And number 4 is not all enterprise resources are enterprise owned infrastructure. Again, that comes back to the same conversation. We might be accessing cloud service, we might be reaching into Amazon Web Service, or we might be going to Amazon Microsoft Azure, or we might have your own VM cloud on premises, whatever that might be. They may not be enterprise owned. We might be leasing space in a platform as a service kind of model. There is a lot of different elements that comes into play. So we don't want to assume anything, and we want to trust nothing in this case. And the number 5 is remote enterprise subject and asset cannot be fully trusted, their location and their network connection. What this has to do with this remote subject should assume that your local network could possibly be hostile. There could be an attacker, there could be a sniffer, there could be a lot of things happening on the network. So we should assume that all traffic is being monitored and potentially captured and modified while it is in transit. Number 6 is asset and workflows moving between the enterprise and non-enterprise infrastructure should have a consistent security policy and posture. Go into the cloud. If you are sitting on-prem or premises and you are logging in and you are logging into an asset that exists within the cloud, you are going off-prem or off-premises. So you are going to Amazon architecture, Microsoft architecture, Google's architecture, whoever it might be. We should not trust, and we should always assume that there is no trust in the connection between resources, assets, subjects, whatever between on-prem and off-prem assets. So we should make sure that the security posture remain intact as we are transitioning from on-premises to off-premises services. So we are moving from the local environment to the cloud environment, and we want to make sure that our security controls are intact and that we do not trust anything in this process. So those are the principles that comes from NIST SP 800-207. Some components that you need to know for the exam within the zero trust architecture start with the policy engine or PE. This determines subject access authorization to a resources. So whatever a subject want to access a resources, the policy engine will make a logical decision based on what's been configured. It will approve and deny, and then it will log that decision so that it can be reviewed later. You have a policy administrator. This maintains communication for the subject and the resources. So the PA will handle the per request basis authentication and authorization. It will create the token, all the different credential, all these different things that happen within the architecture. And lastly, we have the PEP or the policy enforcement point, sometimes called the PEP. It enables communication between subject and resources. So really, this is your client server communication or your gateway, whatever you want to call it, to get the resources. So if you look at the logical diagram, it would look something like this, where you have your PE right here. This is your policy engine where everything is configured. You have your policy administrator, which is handling all your authentication and authorization. And then you have your policy enforcement point here, which is brokering the connection between subject and whatever the resources might be. Okay, pretty simple. And you have a lot of other input as well that comes into a zero trust architecture. A lot of these things are going to be above and beyond what you need to know for the exam. But this is a diagram that comes straight from the NIST SP 800-207. Okay, so from a zero trust perspective, again, when we are looking at this, all data sources and computing services are considered resources. So anything that needs to be accessed on the storage server is a resources, and your subject, whether they are here or they are out on the open internet, depending on what they are trying to access, that's your subject. All of the communication between these need to be secured as well. Access to this object are going to be on a per session basis. So every single time they want to access as a file or a resources of some kind, they will be authenticated and authorized. And then we also want to make sure that we are monitoring all activity, that we are looking at all the logs in terms of behavior analytics. We are looking at different accesses, permission, denies, those kind of things. We want to make sure that we are doing dynamic authentication and authorization, and also that we are collecting as much information as possible within the network itself, so that we can understand how to make the zero trust much more effective. And that take us to the shared responsibility. Now, shared responsibility is about reducing the responsibility of an organization by inheriting or sharing controls. These are also called inherited controls. So these are non-enterprise owned control. When you inherit controls, you can inherit things like physical security, network security, enterprise policy, and so on. And then you can also share controls like patch management, identification, authentication, and configuration management. So where do you see this the most? In the cloud-based deployment. That's the most popular way that shared responsibility happen. For example, if you are leasing a space from Amazon Web Service or from Microsoft Azure, or you are in the Google Cloud platform, whatever it is, and are you worried about the data center? Are you doing physical security in the data center? Of course not. That's their data center, their responsibility. That's an inherited control that you are completing in terms of their physical security. We are not doing it, but they are. However, there could be a time where you are going to share responsibility in terms of you are going to maintain certain platforms, your patch management, maybe your policy coincides with someone else. And now that shared responsibility take place in something where you are. Maybe you have a community cloud and you have multiple people working on it, where some system administrators are responsible for patching, others are responsible for patching other things, and so on and so forth. So, or maybe we are doing federated identification or authentication, where we are all adding into this one single database, and then the federal identification is handling out tokens to all the different users. There's a lot of different way you can spin this, and again, these are topic we will talk about as we go throughout this training. But the important is to understand about the shared responsibility is that you are reducing the responsibility of the organization by inheriting or sharing controls. So the bottom line is to understand the purpose of zero trust architecture, be familiar with different principle or tenet of zero trust architecture, and understand shared responsibility.